So due to student computer issues, I'm not sure if we'll be doing this today or not, but if we do, here's a bit of a tutorial. So the goal is to do a couple of these concept builders related to electrostatics. You need to go to the physicsclassroom.com, where it looks like that. Your account should be over here. You should log in. If you forget your login, you may need to request a password reset, or you can talk to me maybe, but I'd prefer you try to do that. I know we haven't used it in a while. Anyhow, when you log into your account, which is up here, you'll see some tasks below. There should be 2 concept builders that have dates of basically the next day or 2 on them, and they look like this. The first one is called Charge and Charging, and when you click on it, your email should appear here. So that's mine. I have replay on. You do not want to have replay because you want to actually record what you do. So there's 3 different levels. I'm going to ask you to do all 3 levels. So super quick. So for example, an aluminum pie plate is electrically neutral. What can be inferred about the relative number of protons and electrons? Well, that should be equal. So again, super equal with things like that. Easy with things like that. This should take a moment or 2. So a vinyl golf tube, I don't know what that is electrically neutral. I don't know. So some of them are charged. So I'm going to click something like this to get it wrong. Ack. Oh, drats. So now when you do this, if you get something wrong, when you come back to this one, it'll ask you 2 very similar questions. So here, this is negatively charged. What can you infer? Well, I hope if it's negative, electrons are more than protons. If you do get stuck, you can view the directions. You can go to help me, things like that. So help you actually does some helping about this particular question, situation, links to reading in the physics classroom. So in this particular case, I'm going to go back to the main menu. You should not do that until you get done with the level. So next I'm going to go to Getting into the Flow. 2 lab partners are doing a static electricity investigation. They begin with a neutral sample of a foam square. After conducting the procedure, they observe that the foam square has become charged negatively. Which statement explains how this happens? So it's either electrons or protons moving. In solids, it's electrons that move. So if this was neutral and becomes negative, it should be the electrons were added to the object. Dat away. Again, neutral metal sphere becomes charged negatively. So these are all pretty much the same. So I'm going to go back to the main menu again. This one is a little more. So this says 2 students are experimenting with 2 objects, a neutral aluminum pie plate and a positively charged metal sphere. They momentarily touch the metal sphere to the pie plate and pull it away. The pie plate becomes charged positively, so the metal sphere remains positively charged but has less excess positive charge than it previously had. So initially, if this is neutral, if this is positive, there's more protons than electrons. Here at the end, if they are both positively charged, they both should have more positives than negatives. So if the pie plate was neutral and became positive, it is because electrons left. So that is it. So that's kind of the first one. The second concept builder I'm asking you to do is go to Coulomb's law. Again, should look like this. You should not be in the replay mode. So there's a couple of things. One is the charge changes, distance, and then one's where you do things together. I'll do 1 in each level. So charges 1 and 2 attract each other with electrostatic force of 36 units. If 1 is doubled and 2 is tripled, that's basically Q1 Q times Q2 over distance squared, where the distance doesn't change. So this one doubles, this one triples. So 2 times 3 is 6 times as much. 6 times 36 is kind of tough to figure out in your head, so you might need a calculator for that. It should be 216. I don't think most of the numbers are that big. So again, now I'm going to, and these are all kind of like that. This one's halved and tripled, so forth. And again, you can go to the help menus, view directions. I'm going to go to the main menu. And then now think about the distance. Objects 1 and 2 attract each other with electrostatic force of 18 units. If the distance separating them is doubled, the new electrostatic force would be what? Well, it's over the distance squared, so it's over 1 over twice the distance squared, so that's 1/4 the force. So 1/4 of 18 should be 4.5 units. Again, this one, if it's tripled, that would be 1 over 3 squared, so 1/9 the force, so like I think that would be 2 units. But I'm going to go back to the main menu. And then the last one for this is putting it all together. So again, you may want to do some scratch work on paper. Objects 1 and 2 attract each other with electric force of 18 units. If 1 is 1/3 as much, and the charge 2 is doubled, and the distance is doubled, okay, so basically I've got 1/3 times 2 is 2/3. 2/3 divided by 2 squared is 2, I believe, over 12. So that would be 1/6 the amount of force. So I'm going to check that. So it should be 3 units of force. So 18 times 2 divided by 3 divided by 4. And that does give me 3 units. So hopefully that's right. That away. So these are all about proportions. Hopefully that helps.